Organizations around the world are looking to improve their engineering effectiveness, to make the most of their investments, and to increase the value that they deliver to their end users. Given it's the engineers that write the code, it's easy to think of this as a problem that's isolated to the engineering teams. With that mindset, the answer can seem simple. Can't we just invest in more tooling to help them go faster? What if we hired hundreds more of them to work on all of the great ideas that we have? Or even better, can we solve all of our problems by replacing our fellow engineers with AI chatbots? Thinking this problem is isolated to the engineering teams misses out on the bigger picture. Many parts of the organization take part in the journey to deliver software, yet they're often not considered when thinking about improving engineering effectiveness. Why don't we take the entire organization along for that improvement journey? Before we get started on our improvement journey, it's important to be clear on what is meant by effectiveness. Here is effectiveness as defined by the Oxford Dictionary: the degree to which something is successful in producing a desired result. Organizations need to be clear on the outcomes that they're trying to deliver and measure them in relation to their end users. The success of the teams delivering on those outcomes needs to be measured to understand whether they're moving in the right direction. And finally, the degree to which the teams are successful needs to be continuously improved to help them move closer and closer to the desired result. So to put this all together, we have continuously measure and improve the degree to which an organization is successful in achieving the aligned outcomes for the end users by the software they deliver. Why should we be focusing on improving engineering effectiveness? Why now? With fears of a global recession, rising interest rates, and inflation around the world, organizations are desperate to do more with less. We know that organizations that rely on software to succeed can maximize their success by maximizing their engineering effectiveness. The Accelerate State of DevOps report in 2018 found that low-performing engineering teams spend up to 70% of their time on waste, leaving only 30% for value-add delivery. Common forms of this waste that you may deal with on a daily basis include slow and ineffective quality feedback loops, code and architectural tech debt, constant context switching, manual processes, and I could go on. If we can find ways to reduce this waste, we can increase the time our engineering teams focus on value-add delivery, thereby increasing our organizational performance. In the past few years, the industry has seen significant advancements in a number of key aspects on how organizations can deliver software effectively. This has inspired organizations around the world to look inwards and see how they can make the most of these advancements themselves. Some of the advancements you may have noticed include standard frameworks for measuring engineering effectiveness to help organizations understand how their teams are performing. Team topologies has demonstrated the need to reduce extraneous cognitive load and optimize for fast flow by restructuring teams with clear ownership boundaries aligned to value streams. Generative AI-based developer tooling such as GitHub Copilot, AWS Code Whisperer, and of course ChatGPT has provided developers with a way to build software without having to write every line of code, memorize every detail of every API of every programming language, thus greatly improving our productivity. If we can take advantage of the continuous innovations in our industry, we can drive significant improvements in engineering effectiveness, thereby driving significant improvements in organizational performance. While it may not always be obvious, individuals from all parts of the organization take part in the journey to deliver software. Customer need or improvement opportunity can be identified by anyone in the organization, whether they're from the marketing, sales, engineering, or management teams. When we look at the engineering teams, from the prioritization, experimentation, build, and release phases, the effectiveness of the engineering teams is constrained by the alignment between all of the teams involved. While it's the engineering teams ultimately build and ship the software, they can only be as effective as the entire value stream. Of course, it's essential to focus on improving the engineering experience in a loop. However, without also improving the rest of the value stream, we won't maximize the benefits we get from our efforts. So let's seek to improve the entire value stream, and not just the inner loops of the engineering teams, or any one team for that matter. Technology will continue to evolve, and society will evolve with it, driving change in consumer needs. Organizations therefore need to evolve their systems to adapt to these changes, otherwise they risk being left behind. 10 years ago, in the field of artificial intelligence, the industry was excited when AI could detect whether there was a cat or a dog in the image. Now, we can generate detailed 3D artwork using natural language prompts, such as the one on this slide, and we can use it to engage in complex conversations for many tasks, such as programming, brainstorming, summarizing, copywriting, and the list goes on. Software systems are like cities. They're built on top of interconnected infrastructure, which age over time, needing constant maintenance due to usage growth and technological advancements. There is no single way to build a perfect city, nor is there a single way to improve a city. We can't just have a single improvement or modernization effort. It needs to be continuous and holistic across the entire city. While you can't just replace the plumbing of a city and build in new plumbing that transmits water at the speed of light, you can do something similar with software, as it's much more malleable. It may take a while and involve many teams across the organization. However, something like this is still possible. Now, I'm not saying that installing Kubernetes or moving everything to serverless is suddenly going to solve all of your operations issues, though. In fact, it may actually increase the challenges the organization faces if the day-to-day impact of the teams was not properly considered upfront. Software systems therefore need constant care to help them evolve and grow to meet the ever-changing needs of their end users. While it's certainly desirable to seek a silver bullet that will solve all of our problems, they simply do not exist. Instead, we need to foster a culture of continuous improvement within our organizations where leadership is committed to ensuring that the teams have the time and space that they need to experiment, learn continuously, and fail safely without fear of blame, so that our systems and our people get better and better over time. Organizations are complex systems building complex software systems. Could go one step further with this to say that organizations are made up of humans who themselves are complex systems, who then collaborate together to build complex software systems. There are many factors that impact the engineering effectiveness at the individual, team, division, and organization level. Adopting a systems thinking approach can help us understand the bigger picture and drive improvements that work for the entire system, that have the biggest impact. It's an approach that considers the interconnectedness of the elements within the system. In the case of an organization, this involves the humans that deliver the software systems themselves, and the networks of connections between them all. We can use it to identify and address systemic issues by bringing together expertise and perspectives from across the organization to focus on solutions that work for the entire organization, not just a single part of it. A common alternative to systems thinking is analytical thinking, where we break down a problem into smaller parts and focus on solutions for those individual parts. While this certainly has its place, especially for breaking down user stories, it doesn't help us much with complex systems, such as an organization. For example, it could lead us to break down a problem that we're having with cycle time into one that's isolated to the build pipelines. While this is certainly a common problem that requires fixing, it's unlikely to be the sole problem in the entire organization. What would happen if we fix the build pipelines but we left the time-consuming deployment approval process, or continue to take months before feature ideas even reached our teams? Using systems thinking, we can ensure that the improvements that we work on work for the entire organization and not just for a single part of it. Every team that takes part in the journey to deliver software has an impact on the engineering effectiveness, whether it's a positive or a negative one. The ways in which the teams communicate and collaborate needs to be aligned to the organization's strategy to ensure that they're working towards the same outcomes. Using system syncing, we can drive continuous improvements that ensure that all the teams involved in our software delivery journeys are also involved in our improvement journeys. What happens when sales commits to delivering a feature by a certain date without first asking the engineering teams if they can meet it first? How many here have heard a phrase similar to, "We need this yesterday. I already promised the customer we can support it"? Or what happens when a government organization promises to its citizens that a new feature or service will be available by a given date without first knowing if it's feasible? Either they have to break their promise, or the teams have to cut corners, resulting in tech debt the organization will have to pay off in the future. I worked with an organization that organized their engineering teams into horizontal technology layers. There was a web, mobile, and multiple layers of backend teams. It resulted in excessive communications and dependencies between the teams, leading to unnecessary rework, conflicts, and batch deployments. To streamline the delivery, we suggested that they reshape the engineering teams into autonomous product teams. Together, we rolled out the new teams in a staggered approach to reduce change fatigue. We then supported these new teams to establish our own roadmaps for the next few quarters. Once the teams were established, had planned their upcoming work, and got started building their new features. The team that I was part of received a request from marketing. Came with a fixed scope, hard deadline, and support from senior management. We had to drop what we're doing and focus on this urgent task. What went wrong here was that no one had told the other parts of the organization that the engineering teams were reorganized with the intention of empowering them to own their own roadmaps. The marketing team continued to operate in the way that they were used to, which was to effectively plan in complete isolation from the engineering teams. If we don't consider all of the teams involved in our improvement journeys, we risk making changes to one part of the organization without aligning the other related parts to those changes. Just so it's not always the sales or the marketing teams being blamed. A similar challenge can occur when an engineering team releases a breaking change in a shared API that they maintain. All of the teams that depend on this API will have to change focus and update their software to become compatible with these changes. This can also occur if an open source library releases a breaking change, requiring teams to pivot to adapt to these unplanned work. So when we're looking at the improving engineering effectiveness, we need to consider all of the teams involved, whether they're from the engineering functions or the non-engineering functions. A common scenario that I've witnessed, and I'm sure many here have witnessed too, is when an engineering team commits to delivering a certain feature by a certain date without involving the teams that they depend on early on in the process. What tends to happen here is that closer towards a deadline, they realize that they should have involved that dependent team. This can either result in the dependent team having to drop what they were doing and focus on this new work, if they're lucky, or it can result in a delay in the original team's delivery. We need to ensure that all of the teams involved are actually considered when we're looking at improving engineering effectiveness. A similar challenge, another way to fix this problem is actually explore whether the engineering team ownership boundaries can be realigned so that a single team owns everything that is necessary to deliver a certain feature. However, this isn't always possible in complex systems. So where do we start? Organizations need to be clear on the outcomes that they're trying to deliver and how the individual teams will contribute to them. The teams need to determine clear measures that will help them understand how close they are to achieving those outcomes. With those measures, the teams can analyze and understand the challenges that are preventing them from achieving their goals. Once those goals are identified, the teams can work with their management to identify outcomes for improvement with clear measures that will help them track their progress. This process needs to continue over and over again as the organization adopts a culture of continuous improvement, which encourages teams to experiment and adapt to their changing environment and circumstances. There are many techniques that can be used to understand the current state to identify opportunities for improvement. 4 of the common ones we see in use include value stream mapping, measuring effectiveness, visualizing tech debt, and automated scanning. Value stream mapping, personal favorite of mine, is a technique that maps the end-to-end delivery chain from identifying the customer need to delivering the outcome. It takes a holistic approach to identify the feedback loops, pain points, waste, and the time each process takes. We can use it to identify improvements that will help us streamline the process. For example, we can use it to empower teams to collaborate closer and have more autonomy over the decisions that are closest to them. Typically, when I run these workshops, we involve stakeholders from all parts of the organization that are involved in the software delivery journey. And together, we identify that almost every step of the way, there is a waste that can be eliminated that wasn't immediately obvious beforehand. When you've been part of a team or an organization for a while, it can be easy to miss how different teams in the organization can impact the effectiveness of your own. Taking a step back and mapping the entire process can provide a fresh visual perspective. There's active research in determining how to best measure engineering effectiveness of teams and organizations. Common frameworks include SPACE and the Draw of 4 key metrics, and there's a more recent framework called DevX. Build and code metrics can also be used to identify how long it takes to deliver code to production. However, this also needs to be augmented with system and user metrics to provide a more holistic view. Teams can visualize the tech debt within their system using tech debt walls to help ensure that the issues remain visible and to enable them to continuously improve them. Automated code and architecture scanning tooling can be used to identify tech debt within our code and our system architecture, such as excessive coupling and high levels of code complexity. These findings can then be prioritized among the known tech debt within the system. Making use of these techniques, we can identify the key challenges within our systems and the ways in which the teams can address them. Now that we have an understanding of the current state, let's make use of systems thinking to understand how the different teams within our organization can contribute to engineering effectiveness. While I won't be providing an exhaustive list of every possible role in every organization around the world, as I was only given 35 minutes to talk today, I'd like to share how some common roles can contribute to demonstrate that it's a journey for the entire organization. Let's start with the engineers themselves. The engineers can seek to continuously refactor and clean up their code bases, thereby reducing tech debt and preventing it from accumulating in the future by adopting linting and static analysis tooling. While a common goal of software is to automate manual business processes, it can be common for engineering teams to, over time, adopt manual processes of their own that could benefit from such automation. Each of these manual processes adds a risk of human error and makes it harder to maintain and scale systems over time. It's not necessary to take a big manual process and dedicate effort to automate every aspect of it all at once, though. Taking a continuous improvement mindset, we can instead break down that process into smaller parts, and each time an engineer encounters one of those parts, they can automate a small aspect of it, and eventually that manual process will be replaced by a fully automated one. I worked with a client team at an organization that was responsible for maintaining a system that required a careful chain of manual processes to keep it alive. When I asked the teams why these processes exist and why they haven't been automated yet, their general response was they hadn't been given the time to do so. For certain processes, there wasn't even a clear understanding of why they exist, whether they're still relevant. There were certainly ways that they could improve their system, and the teams themselves recognized them, but they didn't feel that they had the autonomy to do so. This is a sign of a fault in the organizational system, where continuous improvement is not encouraged, and teams are not empowered to improve the systems that they work with day to day. Leaders need to empower their teams to continuously seek opportunities to improve their systems. Otherwise, the systems will continue to rot, and the engineering teams will become complacent. You don't even have to write all these automation scripts yourself. Why not ask an AI chatbot to do it for you instead? I recently pitted ChatGPT and Bard against each other. Tell me write automation scripts for a legacy web server that isn't used often these days. It's quite fascinating what they can come up with. They don't always get it right, but they seem to enjoy being corrected, so feel free to let them know if they got it wrong. It saved me countless hours of reading through the confusing and outdated documentation. There are many ways that engineers can improve the systems that they work with day to day, but it's essential for leaders to provide them the time and the autonomy to do so. Now, I'm not saying that everything needs to be automated. There are some manual tasks that don't take long, and we don't perform often enough that may not be worth automating. As the time to automate it could actually end up being more than the time we take to actually perform that task, particularly if it's a complex task that's not easy to automate. When looking at automating manual processes, do consider whether it needs to be automated at all and what value that automation will provide when compared to the other improvement opportunities that have been identified. How many developers here have joined an organization only to be presented with a 50-item checklist on how to set up their laptops? What a way to welcome someone to the team. Engineers can seek to automate these steps by scripting the tooling installation and commands needed to build and run the system. To ensure that engineers are using the same versions of dependencies, consider adopting containerized local development environment that will standardize them. Taking this one step further, we can adopt cloud-based development environments that automatically provision pre-configured virtual machines ready to go. We can even make use of these virtual machines to test specific changes on specific branches without having to have that code locally. While this can't be completed overnight, if each time an engineer encounters one of these manual processes, they seek to automate it, eventually it will be possible to perform these tasks by running a single script or even pressing a single button. These principles can be applied to other manual engineering tasks as well, whether they're deployment or operations tasks. So let's seek to reduce the amount of time that our engineers spend on mundane, repetitive tasks, and instead give them more time to focus on those that will add value to our organizations and to our end users. Common role within an organization that focuses on ensuring that the software that's delivered is of high quality is that of a quality analyst. Typically, this role is responsible for manually testing every change that the engineers work on before it's deployed to production. While it's important to ensure that the software that's delivered is of high quality, is it essential for all of that testing to be manual? Many forms of testing can be automated, which will improve the velocity of our teams and the underlying quality of our system, as automated testing tends to be more reliable and repeatable. Not all forms of testing can or should be automated, though. A common example of this is usability testing, where we need humans to apply empathy to understand how a user experiences our software, which computers aren't very good at. Similar to manual engineering processes, QAs can automate. Every time a QA encounters a manual test, they can seek to automate a small aspect of it, and then eventually over time, they'll have a fully automated regression test suite. They can foster a culture in the team that focuses on high-quality software delivery, encouraging teams to shift quality left, focusing on all quality attributes, whether it's functional, performance, security, resilience, or reliability. Product owners need to be aware of the organization's strategy and work with the engineers to align work to that strategy. When they're aware of the technical limitations and constraints of the system, they can ensure that the upcoming work is realistic and achievable, and that it doesn't unnecessarily increase the complexity of our systems. When they collaborate with engineers to devise solutions to end-user problems, they can uncover a variety of ways to solve that same problem. In many cases, they may find a simple solution to what seemed like a hard problem to begin with. It can be tempting to focus all of our efforts on building new features and improving the user experience. If all we did was improve the user experience, though, we'd actually end up increasing the time it takes us to deliver value to our end users, as the underlying quality of the system will be neglected. It's important to ensure that the teams have the time to work on both user-facing and technical improvements. Common practice here is to dedicate 20% of the team's time to focusing on these technical improvements. Teams that maintain a tech debt wall can help to ensure that these issues remain visible and that they are continuously prioritized with their product owners. The most effective leads I've worked with are those that work closely with the team to help them identify the challenges that they face day to day and encourage them to raise their concerns often so that they can be addressed. They provide the team time, space, and psychological safety to experiment and drive continuous improvements to optimize how the team works together to deliver software. They can seek to optimize feedback loops by encouraging collaborative processes such as pair programming and cross-team sharing. They can drive collaboration with dependent teams to prioritize improvements that will help the team. Common example here is working with the platform teams to share the challenges that they're having provisioning infrastructure and advocate for these improvements to be prioritized in the upcoming roadmap. When the teams are blocked due to insufficient resources, tooling, or learning opportunities, they can work with the management to remove these blockers to improve the flow of value delivery. To justify why technical improvements are worth spending time on, tech leads need to be able to translate those improvements into the ways in which they will help the organization meet their business goals. A common example here is working with stakeholders to justify why it's worth spending time to improve the build pipelines. We could talk about how the current build pipelines are built using legacy technology, and there's more modern technology that could replace them. Or instead, we can talk about how improving the build pipelines will reduce the time it takes us to deliver value to our end users and reduce the time it takes us to respond to incidents. A simple change in framing can have a significant impact on whether this will resonate with non-technical stakeholders and whether the team will be given the time to work on them. Management plays a crucial role in establishing a culture of continuous improvement, which is essential for improving engineering effectiveness. They need to provide the team the time and space to identify pain points and experiment on solutions to improve them. When they work with different parts of the organization, they can connect dependent teams together through cross-team sharing and collaboration sessions, ensuring that they are learning from each other and working on the highest priority items for the organization. Teams need dedicated time to work on improving their systems and resolving tech debt, which management can provide by explicitly prioritizing that work. They can work closely with the teams to measure their developer experience, help them prioritize improvement efforts, and identify potential organization-wide improvements. For example, if management sees that multiple teams are experiencing a similar issue, they can look for solutions that address this at the organization-wide level, thus relieving the teams from this burden. Business operations teams, such as marketing, sales, finance, and support teams, can also contribute to engineering effectiveness. They can work with the engineering teams to understand the technical capabilities and limitations of the system. With this understanding, they can ensure that the ideas that they discuss with end users are actually feasible. They can then work with the engineers to devise optimal solutions to those end user problems with achievable milestones that are aligned to the organization's business and technology strategy. Sharing product ideas early and often can help ensure that the ideas are properly considered and that they are factored into the upcoming roadmap without resulting in disruptions to existing work. Executives have the ability to impact organization-wide improvements as they have visibility of the entire organization. Tech executives can work with system architects to reorganize the engineering teams, making use of principles such as domain-driven design, team topologies, and Conway's law. They can optimize teams for fast flow, aligned to domain boundaries that are aligned with the organization's business capabilities and architectural principles. They can move from project-based to long-lived product team-based funding, establishing a sense of ownership within the teams, and enabling them to continuously work on the highest priority items without having to constantly justify funding for each one. They can identify and address systemic issues that are not immediately visible to teams, or where the teams themselves don't have the authority to address themselves, particularly those that limit psychological safety within the teams, which is essential for continuous improvement, as this cannot be established without executive leadership support. They can invest in platform engineering, including business and developer platforms, thus reducing the cognitive load of the teams. They need to ensure that the platforms have the dedicated support and development that they need to thrive. Ankit, who will be speaking right after me, will be providing practical guidance on how to build such developer platforms. They can invest in organization-wide improvements to developer experience, such as developer portals, cloud computing, and generative AI. And they can decentralize decision-making within the organization, moving from a top-down hierarchical structure to a bottom-up, where teams are empowered with the autonomy to drive changes that are closest to them. Using systems thinking, we can understand the constraints impacting engineering effectiveness and use it to drive continuous improvements that result in long-lasting change. We need to consider this a journey, not a destination, as a single improvement effort won't solve all of our problems, and we need to bring the entire organization along for that journey together. Thank you.